Hello everyone, welcome to my YouTube channel Zenith GATE Mechanical. Continuation with the concept and question series. A uniform wheel of 60 centimeter diameter and weight 1000 Newton resting against a rectangular block this 15 centimeter height, which is lying on a horizontal plane as shown in the figure. It is to be pulled over this block by a horizontal force P applied to the end of string. That means you are applying some particular force so that this uniform wheel will pull over this block. Then you have to calculate, find the force P when the wheel is just about to roll over the block. Okay, now you can observe when it is rolling over this particular block, then there will be no contact at B point. And this is very, very important. So contact at B point will be 0 means there will be no normal reaction. Okay, so this is the force P which is acting at the top. This point is D. So one force which is acting in downward, this is nothing but the 1000 Newton. If it is making a contact at A point, then there will be one normal reaction. And this normal reaction will pass through the D point. Because you can see here, the force 1000 Newton and P are intersecting at this point. So this force should be passed through the D point. Okay, so let us suppose this is nothing but the normal reaction at. What is this distance? This distance is given as 15 centimeter. And if this is 15, so I can say this is also a 15 centimeter because the radius is 30. If I will join this point, D point to A, so let us suppose this angle is theta. This angle is theta. So I want to calculate the angle theta because this force is known to you. This is passing through this point. So at this point, I will apply the Lami's theorem. But before that, you have to know this angle theta. So now I will consider in triangle CEA, CE square plus AE square is equal to AC square. AC is nothing but which is already known to you. This is 30 square minus AE value you have to calculate and CE is 15 square. So can I calculate the AE value? This is 900. This is 225 of square root. So you will get the value 25.981 centimeters. Okay, so AE value you have calculated. Now, if I will consider tan theta, which is nothing but AE divided by DE. So theta value is nothing but AE is given as 25.98. What is the value of DE? DE is 45. So from here, you will get the theta values 30 degree. So once you know the 30 degree, so you can apply the Lami's theorem at this D point. So let me draw first of all, what are the forces acting at D? So here will be one P force. This is the force of 1000 Newton and one normal reaction which is passing through this point, nothing but NA. What is this angle? This angle is 30 degree. You can see here. So if this is 30 degree, that means this is passing through the D point. So the normal reaction is making angle of 30 degree with the vertical. So 30 degree. Now you can use the Lami's theorem. So by Lami's theorem, the normal reaction divided by sine of 90, P divided by sine of 150, okay, 90 plus 60 is equal to 1000 divided by sine of 120. Sine of 150 divided by sine of 120. Okay, so 1000. Sine 150 is nothing but the cos 60. So cos 60 is 1 by 2. And this is sine 120 is nothing but sine 90 plus 30, cos 30. This is nothing but the root 3 by 2. So you will get 1000 divided by root 3, which is approximately 577.4 Newton. So this force you have to apply at the end of this wheel so that the wheel will roll over the block. The force is acting at the top of this wheel. Let us suppose if the force which is acting at the center of the wheel, okay, so that will be the next part. A uniform wheel of 60 centimeter diameter whose weight is 1000 Newton resting against a rectangular obstacle 15 centimeter, the least force required, that means minimum force required, which when acting through the center of wheel will just turn the wheel over the corner of block. Okay, so in the similar manner, again you will draw the free body diagram of this wheel. What are the forces acting? Here will be one force P which is acting, and one more is 1000 Newton, that is the weight of this wheel, and there is a normal reaction. So these two forces are passing through the point C. So it should pass to the point C only. There is a normal reaction which is Na. Na. Now this distance is known to you. Okay, so the same points I am taking CAE, CA, and this value is E. This is B, and this is nothing but the D. So AE value already calculated. AE is nothing but 25.98 centimeter. CA value is 30 centimeter. So can I calculate this theta value? So sine theta is nothing but perpendicular by hypotenuse, which is AC. So theta value, once you will solve, you will get 59.99 or approximately 60 degrees. Okay, so if you apply the Lami's theorem at point C, your problem will be solved. So let us suppose this is the P force. Here will be one normal reaction, and here is nothing but the 1000 Newton. Okay, so this is the 60 degree. 59.99 is approximate 60 degree. So if I will apply the Lami's theorem, so P by sine of 120 is equal to NA divided by sine of 150. Okay, so this point is nothing but C only. 1000 divided by, what is this angle? Sine of 90 degree. So from here you will get the P value. You can also calculate the normal reaction also in this question, but in this problem you have to calculate what is the least force you have to apply. So P value you have to calculate, which is nothing but 1000 into sine of 120. Okay, so P value is nothing but 1000 into sine of 120, which is nothing but sine 90 plus 30, which is cos 30. So 1000 cos 30. Cos 30 is root 3 by 2. That means 500 root 3. So which is approximately 866 Newton. 866 Newton. Okay. So you have to apply the 866 Newton so that this wheel will turn and roll over this particular block. Now the next question is, here are the two cylinders are kept in a container as shown in the figure given below. Top cylinder has a weight of W, that means this cylinder having weight is W, and bottom cylinder has a weight of 2W. What is the reaction at A point? Okay, so you have to calculate the reaction at A point. So for this question, what you have to do? First of all, you have to draw the free body diagram of this small cylinder, and then after that, free body diagram of this bottom cylinder. Okay. So let us suppose so these are the two cylinders. So which is making a contact at point A, and this point I'm just considering C. Let us suppose this point is D and this point is B. So radius of both the cylinder is given. So this radius is 30 and this radius is 20. Okay, all the dimensions are in mm. Now, what is this distance? This distance is given as 80 mm. What about this? So this is nothing but the 20 mm only, which is the radius of top cylinder. Okay, so if this is 20 mm, what is this value? This value is 30 mm. Okay, 30 mm radius of bottom cylinder. So if I will join this point, this angle you have to calculate. What is the angle? O1 is the center of top cylinder and O2 is the center of the bottom cylinder. Okay, so can I say sine theta is equal to perpendicular by hypotenuse? Perpendicular is nothing but, let us suppose this point is E. So O2E perpendicular by hypotenuse is O1 O2. So from here theta value you will get, because this value is 30 and this is 50. Okay, so this is 30, this is 20, 50, and this value is 30. So you will get this theta value. So theta value is 36.86 degree. Now, if you draw the free body diagram of this top cylinder, what are the forces acting? One force which is acting as the normal reaction at D point, and this O1, the weight of this cylinder is acting downward, W, and here will be one normal reaction. So this is the normal reaction at C. That means the contact between these two cylinders. So this normal reaction which will be offered by this bottom cylinder to the top one. Similarly, the same reaction will be acting over this cylinder from the top cylinder. Okay. Okay. So this is angle theta. So this is O1. The forces which is acting at O1. One is the W force. Another is the ND, normal reaction at D, and the normal reaction at C. And this angle is nothing but theta. Now I can use the Lami's theorem. That's why I have calculated the, first of all, theta value. So ND divided by sine of 180 minus theta. And what is the value of theta? Theta is 36.86 degree. Similarly, W divided by sine of 90 plus theta, and NC value is nothing but sine of 90 degree. Okay. From here, you will get the NC value, which is nothing but W divided by sine 90 is 1, sine 90 plus theta, which is nothing but 90 plus 36.86, you will get 0.8. Okay, so the normal reaction at C you have calculated. Now you will apply the forces on this bottom cylinder. What are the forces acting? One force which is acting downward, which is nothing but the weight of this cylinder 2W, and there will be one normal reaction NA. You can see here, there will be one normal reaction, and there is a one more normal reaction at this point, and there is a contact force between this C point. So this is the NC, which making same angle theta, which you have calculated 36.86. And here will be one normal reaction, which is nothing but NB. So you have to calculate what is the normal reaction at A point. What is the reaction at A point? What is the reaction at A point? So NC value, which is known to you in terms of W. So can I write summation of force in X direction 0, NC sine of theta is equal to NA. What I have done, I'm just equating the force in the X direction. So from here you will get the NA value, because NC is W by 0.8 and sine theta means 36.86. So once you will solve, you will get 0.75 W. So what is the value of NA here? So NA value is nothing but 3W by 4. Because 0.75 I can write 3W by 4. Why? Because if you see the options, these options are given in terms of 3W by 4, 2.8, 2.5, and 3. So what will be the correct answer for this question? The option D. So the choice D is the correct answer for this question. So this series truly help you in your exam preparation. So don't forget to like, share, and subscribe. Thank you so much.